Hello everyone, this is Tahir Iswat from Daffodil International University and welcome to the video of understanding Caesar Cipher algorithm. It was first invented by Julius Caesar. This algorithm is one of the earliest known and the simplest techniques. Now, what is Caesar Cipher? The Caesar Cipher is a substitution cipher where each letter in the plain text is shifted by a certain alphabet. It's a type of symmetric key encryption, meaning the same key is used for both encryption and decryption. The key for the Caesar cipher is a number. Now, what is encryption? Plain text to cipher text transfer process with an algorithm and a particular key. And the decryption process is exactly opposite of the encryption. Encryption process. Formula C equals to P plus K, where C is cipher text, P is plain text, and K is the key. If the result of the C is greater than 26, which is the base of alphabets, we would mod the result to get a value in range. If the result of C is smaller than 0, we do this equation like C plus 26 into multiplier of C. Here we need three things: plain text, key, and the starting alphabetical value, which is 0. Now in the following table, we have placed the initial given value of plain text and key. After that, we will place the corresponding value for each letter of the plain text, which is A for 1, P for 16, P for 16, L for 12, and E for 5. Moving on, we will simply do the equation of P plus K. As we see, no value is greater than 26 or smaller than 0. We will simply convert the numbers with the corresponding alphabetical value. And now we have the ciphertext named FUUQJ. Moving on to the decryption process. Here is the formula: P equals to C minus K, where C is ciphertext, P is plaintext, and K is the key. And the rules for the decryption process is same as the encryption process. Here we need three things: the plain, the ciphertext, the key, and the starting alphabetical value, which is A equals to 0. Now in the following table, we have again placed the initial given value of ciphertext and key. After that, we place the corresponding value for each letter of the ciphertext, which is F for 6, U for 21, E for 21, Q for 17, Z for 10. Moving on, we will simply do the equation of C minus K. As we can see, no value is greater than 26 or smaller than 0. We will simply convert the numbers with the corresponding alphabetical value. And here we have got the plain text again. Let's take a look through the code for Caesar cipher algorithm. Here we have a main class and three methods, including main method. First of all, the encryption method. In the encryption method, we have a scanner for taking user input as plain text and key. Then we have a for loop, which will run until the plain text length. And for every iteration, it will take the current character from the plain text. And we have a condition that if the current character is a letter. Now we have the equation here, current character minus A. This part of the expression converts the current character to a numerical value by subtracting the ASCII value of the lowercase letter a. This effectively maps A to 0, B to 1, C to 2, and so on, allowing us to perform mathematical operations of the characters as if there were numbers plus key. Here, key is the amount by which we want to shift the character. For example, if the key is 3, then A would be shifted to D and B would be shifted to E. Now, plus 26 mod 26. Adding 26 before taking the modulo operation ensures that the result is always positive. The module operation, module 26, ensures that if the result of the addition exceeds 25, the number of letters in the English alphabet minus 1, it wraps around. For example, if the result is 27, taking 27 mod 26 gives 1, effectively wrap the alphabet. After that, plus A. Finally, we add the ASCII value of the A to bring the result back in the range of lowercase ASCII character. This effectively converts the numerical value back into a character. On the other hand, the decryption process is the opposite of the encryption. Just we have slightly changed the formula from addition to subtraction. Now let's try to execute this. 1 for encryption, plain text is equals to APPLE. Let's take 5 for the key, and here we have the ciphertext called FUUQZ. Let's try this again for the decryption process. 2 for decryption, FUUQZ for the ciphertext, and 5 for the value. And here we got the apple again. So this is a completely working code. Thank you.